Hello, and welcome to Game Engine and Application Scripting Languages. The similarities and differences between Unreal Engine 4's Blueprint, Unreal Engine 3's Kismet, and 3ds Max's MaxScript make the creation of video game content and animation seamless with the use of their own integrated development environment. The engine or 3D graphics software on which these scripting languages are built upon has some similarities and some differences. Let's define each tool we are covering for clarity. 3ds Max is a 3D modeling software package made by Autodesk that provides a comprehensive modeling, animation, simulation, rendering solution for games, film, and motion graphic artists. UDK, which stands for Unreal Developers Kit, is the last iteration of the Unreal 3 engine, and UE4, which stands for Unreal Engine 4, is the latest version of Epic's Unreal Engine. A game engine is a programming-based technology built to combine graphics, artificial intelligence, physics, networking, and editor, scripting language, shaders, audio, animation, rendering, and other technologies used to create games based on the needs of the developer. Let's take a look at a few examples. Let's take a look at Unreal Engine 3's Kismet. Kismet is a proprietary visual scripting language built for video game artists and designers to help them prototype games without programming. Functions can be called to check conditions, play cutscenes, and even create the user interface. Kismet's downfall is the ability or the inability to reuse the scripts created for the interactive environment. Let's compare these very robust systems and look at some examples in real time. All three of the system's scripting languages are proprietary to the engine or application it is built upon. In the case of recreating content, UDK's Kismet does not allow reusable content as it pertains to physical content in the game level. This is especially useful when you need to create repetitive features such as opening doors or elevators. Let's take a look at a Kismet scripting language example and the work needed to recreate a gameplay element. Let's take a look at Kismet. Here we have a scripted event to open sliding doors in order to enter the restaurant. We will have to recreate the script and copy the physical doors to the new location in order to reproduce the same opening door sequence. Let's take a look at the physical elements that are in the game level and then compare them to what is in Kismet and show the sequence of events that will take place. First, we have a trigger volume that has been placed in front of the door before you enter the restaurant. Of course, you have the two sliding doors that will slide open once you enter the trigger volume. These sliding doors will open with a matinee that has been produced to animate those two doors. Simultaneously, an event track with sound included will play along with the animated doors opening. Once you enter the building and walk through the doors, you'll actually walk into another trigger volume which will trigger another sound that indicates you entering the restaurant. Once you exit the trigger volume, the doors will then reclose. I have a smaller volume here, so for the sake of the example, let's increase the size of this volume so that we can turn around and have time enough to see the door closing. So let's increase that size. I've increased the volume. Now let's go ahead. We have to rebuild our level, and we will play through the sequence once we walk through the Kismet that has been set up. Okay, before we physically test the level, let's take a look at our Kismet and see what the sequence of events that will take place when we walk through our first trigger volume through the doors and then exit or enter the restaurant and exit the trigger volume that is inside the restaurant. So first you'll see here the trigger door opening event here, that is the trigger volume that is outside of the restaurant. It then triggers the matinee that controls the two doors that will open. Let's take a look at that real quick. So if we go outside the restaurant here and test our matinee, as you can see, it is all set up and ready to go. Let's close this and continue with our sequence. Once the actual matinee has completed and you walk through the front door and into the trigger volume that is inside the doorway here, highlighted in green, it'll then close the door and it will actually play a sound and then close the door. Let's take a look at that sequence now. Now let's go ahead and initiate the gameplay, which is the opening of the door. Walk up to the door. As you can see from the output so far, the doors are opening, or actually the trigger door is opening, and then the doors are opening based on the matinee. Now once we walk into the trigger volume, then another sequence is triggered and then the doors close. Now let's take a look at 3ds Max's MaxScript. MaxScript is a text-based system derived from the activity performed in the application. The MaxScript listener window is an interactive interpreter for the MaxScript language. Let's take a look here at the bottom left here. I'm going to right click and open up the listener. The interface performs similarly to a command prompt environment and it executes the command similar to BASIC. The macro recorder captures or records actions performed, generating MaxScript commands that can be used to perform repetitive actions such as placing sidewalks or buildings, trees, or signs into a scene. Let's take a look at MaxScript in action based on an example. First, we're going to go ahead and create a simple box and show you what happens when we create said box in the listener window. So once I created the box, it actually records the entire process. And this is how MaxScript executes its commands based on the actions that are performed inside the application. So with that in mind, I'm going to go ahead and delete this particular cube, and then we're going to clear all of the windows here, and we're going to open up a pre-made script and execute that script based on what we've seen in this simple example. So I'm going to go ahead and move MaxScript Listener over, and I'm actually going to right click down here in the bottom left corner and open up the editor. The editor is actually the MaxScript editor where you will place all of the commands needed to execute an entire script. Once you've created your entire script, you'll actually execute it by hitting Control E or Evaluate All. You can also evaluate a line at a time by hitting Shift Enter. Let's take a look. I'm going to move these two off of the screen. And I'm going to execute the command and take a look at what we've created based on my script. As you can see, I've created a cube that has extruded all of the corners of this cube. Now, let's take a look at the script. The script itself, again, has created a box. It's actually named the object, gone down to the modification panel, selected the sub-object level, number 4 out of Edit Poly, selected all of the faces that will be extruded, performs the extrude face at 1.5, and then committed those changes. This script can actually be used and reused in any file that you create. So that's where the similarities of MaxScript and Unreal Engine 4's Blueprint class have a lot in common, because they can be reused from file to file or level to level in the case of Blueprint. Okay, let's take a look at the output, or what's been printed based on that. As you can see down here, it's actually showing that the box has been created at a particular coordinate, in this case 0, 0, 0. It's been named Rubik D. It's confirming that that's okay. Confirming that the actual selection number 4 has been selected out of the Edit Poly selection mode. And then all of the true statements have been printed to the screen to represent what has been extruded on the box. Once we said OK, we've actually selected we've actually confirmed also the amount of, or the length of the extrusion. Let's take a look at why this scripting is so great. I've created a new file, and I'm actually going to go ahead and execute this again and show you that a new file will allow me to reuse this script once again. Now let's take a look at Unreal Engine 4 and Blueprint class. Blueprint works in layers, so to speak, to give the user a wide range of options, from intermediate to professional level programming. Like Kismet, Blueprint behaves in the same manner, with the advantages of reusing functions to perform repetitive interactivity. Let's take a look at an example. I'm going to walk over here to the garage where I have a preset or pre-made Blueprint class for a wall-mounted light. What's going to happen is I'm going to walk into the trigger volume that I left open to show you where the trigger volume is, and I'm going to walk into it, and two things are going to happen. First thing is, we're going to see a display that's going to let us know what key we can press to activate the light. And the other thing is going to be, the other action that's going to happen is, while standing in the trigger volume, it's going to activate or enable the input that I'm able to do with the particular key. Let's take a look. So once I step into the volume, press F to toggle will allow me to press F and turn on the light. As you can see, the light is turned on, and it actually has a blue color to it. Blueprint also allows us to change colors of lights on the fly in the level if we choose to. And once you see that I've stepped out of the volume, the words go away, but the light remains on. I can then step back into the volume. You'll see the words to let me know that I can press F again to toggle that light off. Let's do that now. And as you can see, the light is turned off. I can step out of the volume and no light unless I want to go back into the volume and turn it on. Now let's take a look at reusing this blueprint class to place a light anywhere in the world without recreating this inside a blueprint or recreating the physical aspects. So now what we're going to do is go to the content browser, and in content browser, under the blueprints folder where I've created this wall sconce blueprint class, I can actually drag this class out into the world and place another light, and actually control that light in the same manner that the original blueprint class has been created. But before I do that, I'd like to show you how the entire function behaves in our blueprint display. Let's take a look at the blueprint class event graph. As you can see, it has similar look and feel to UDK's Kismet system, except Blueprint allows the user to see the flow of events in real time to ensure that the functions are executing properly. In this example, I've created a blueprint class for a wall light and assigned a function to turn the light on and off once you are within the trigger volume, giving the implication that the player is close enough to control the light. With the blueprint created and saved, I can place a light in another location with the same controls and change the color if need be. Let's take a look at this example now. So once the player has crossed the threshold of the trigger volume, you'll see that it has fired off from the trigger volume on component begin overlap and has enabled the F key to allow the user to turn the light on. Let's take a look. Press F, and as you can see, the press F function has fired, toggling the visibility of the light. Now, once we back out of the trigger volume, the on component end overlap trigger volume fires, disabling the input. This keeps the player from hitting the F key while just arbitrarily walking around the level. So let's take a look at that once more. Walk into the volume, hit F, turn it off, and now step out of the volume and it has disabled the F key trigger. Now I will show you that in real time along with the firing of the functions. Now that we've seen a breakdown of the wall sconce blueprint class, let's take advantage of this and show you its strengths. I'm going to go ahead and open up our toolbox or our content browser, which is under our toolbox, and bring in our toolbar rather, and bring in our blueprint under blueprints folder. wall sconce. The great thing about blueprints and Unreal 4 is that I can actually take this wall sconce and drag it into the level and use it. So let's take a look. Let's go ahead and find a place to place another light. How about right over here? Let's get rid of this light in front of this first store here. We're going to go ahead and drag the wall sconce in to the world and hit the N button to place it against the wall. Then I'm going to drag it down to where it makes sense. And then we're going to rebuild this level and test it. Now that our level is rebuilt, let's go ahead and test our newly placed light. And as you can see, it could use some adjustments in terms of the awning itself and the height of this light. But as you can see, it does work. And here is the first light we created. And I can turn that light on. I can turn this light on. And maybe there's a third or fourth light that I'll place in the world and put a condition on turning all the lights on, and then maybe spawning some enemies or opening a door. Thank you for watching.